Welcome back, folks. This is Anita's exercise physiology class, or most famously known as AEPC 9,
The Clink.
And Pepper here is going to give us an intense rundown on what we're going to watch today.
Yeah, that's right, Cotton. I can't wait. Okay, so what we're going to be talking about today is the intense game between muscle contraction and relaxation. Let's get started, shall we?
Well, let's start off with the sac-like vesicles within the terminal axon release acetylcholine. Acetylcholine is a key player in this game, man. Acetylcholine diffuses across the synaptic cleft and attaches to specialized acetylcholine receptors on the sarcolemma.
And I can't wait for that part, Cotton. It's so motivating to me. But next, muscle action potential depolarizes transverse tubules at the AI junction of the sarcomere. And this is where acetylcholine is going to get caught up again in this kind of play.
And let's not forget, man, depolarization of the T-tubule system causes calcium 2+ to release from the sarcoplasmic reticulum's lateral sacs. That's key.
That is definitely key. Calcium 2+ is one of our key players, especially when they bind to the troponin tropomyosin in the actin filaments. This releases the inhibition that prevented actin from combining with myosin, two of our other players.
Now we're getting to the key part here, man. During muscle action, actin combines with myosin ATPase to split ATP with energy release. Tension created from this energy release produces myosin cross-bridge movement, a key part of this game, man.
Absolutely key. And next, we're going to see ATP is going to bind with myosin at the myosin cross-bridge, breaking the actin-myosin bond, allowing the cross-bridge to dissociate from actin. This will lead to sliding of thick and thin filaments, causing muscle shortening, and it is just an intense play in this game, Cotton!
And let's not forget, the cross-bridge activation continues. Like, it freaking continues, man. It keeps going when the concentration of calcium 2+ remains high. I mean, this is from the membrane depolarization. It's kind of key to remember that depolarization, man. And then to inhibit action of the troponin-tropomyosin complex. I mean, it freaking inhibits it, man. That is so freaking key on muscle contraction.
Huge. Absolutely huge. We can definitely tell how acetylcholine and calcium 2+ are intense players in this kind of game, Cotton. And it's getting so intense, I don't know if I can even handle it anymore.
No, our muscles have to release now. They have to release.
They have to release. So what are they going to do? They're going to release because they have to, Cotton. So we're going to get over there and we're going to start talking about the releasing because this kind of huge mess just has to stop at some point. Cotton!
When muscle stimulation finally ceases, man, like finally, calcium 2+ moves back into the sarcoplasmic reticulum's lateral sacs through active transport, requiring ATP hydrolysis, a key point.
Absolutely key. And finally, what we're going to see is calcium 2+ removal restores inhibitory action of troponin tropomyosin. In the presence of ATP, actin and myosin remain in the dissociated relaxed state, and that is where our game ends, and the muscles are released.
But if you think about it, man, like, this was an intense game, and it's always continuing. But this is AEPC 9, The Clink.
And we can't wait to see you next time when we're talking about the brain and nociceptors.